Okay, as we are carrying on the discussion regarding CHD exam preparation, what we already know that we have to study these three handbooks, and we have to also focus ASHA Standard 55, 62.1, and 90.1. Today, we are going to start our lecture with ASHA Standard Handbook, HVAC System and Equipment. Right. So, chapter 1 that we have is about systems and equipment. So there is a handbook on this. The handbook is 986 pages. We don't have to study all these chapters and everything. We just have to study the important parts. Now, how the note is written, that is actually important, how you should prepare yourself. First of all, notes are written by chapter. So let's say this one is system and equipment. So system and equipment handbook is this one. And the first slide is about Chapter 1, HVAC system analysis and selection. So if you go in the handbook, you'll find Chapter 1, HVAC system analysis and selection. Now, if you go to the Chapter 1, you'll find only the necessary information in this notebook, not everything. So from Chapter 1, I have picked up this one slide and two slides, three slides, four slides. Yeah, these four slides are only the necessary information from this Chapter 1. Chapter 1 might have so many things written. I have copied out only the important parts. And one thing I must mention at this point, everything that is written here is actually directly referred from this standard. I did not added anything. I did not make any paraphrase. It is all about from ASHRAE, and all the reference is taken directly from ASHRAE. Nothing is been added by me or modified by me. It is as it is in the book. Like if you copy it from here and search in here, you exactly find where it is copied from. That's it. Okay, so slide 1, let's focus on these as I progress with the slide. Okay, let me make it full screen first. Yeah, it is better now. Okay, as I progress with the class, I will definitely mention what to memorize and what to practice. There's something that is good to know, and there's something must know, and there's something must be memorized. Let's talk about this slide, okay? The very first thing, design engineer's responsibility. So as a HVAC designer, what are your responsibilities? For considering various systems and equipment and recommendation on one or more system options that will meet the project goal and perform per the project intent, design intent. Okay, let me make it very simple for you. At the beginning of the project, HVAC designer must ensure the system that is required for the project. So the HVAC designer will study the project and offer to the customer that these are sets of solution. For example, if I go to a commercial project, I study the project, I offer to the customer that either you can go for VRF system or you can go for chilled water based system. And depending on the various factor, the customer will make its call. So the system selection will come at the very beginning of the project. That's why it is a responsibility of design engineer, and design engineer must be involved at the very beginning of the project, not in the middle of the project. And later on, we will discuss on how can you represent your data to the customer so that the customer can take the better response from available data. Again, as you proceed the design, design data for occupant comfort. Actually, in most cases, the prime factor is the occupant factor. In few cases, the factor is the important factors are products. Like if you go for the industry, the main focus will be the product. And if you go for the commercial spaces and other spaces, the main focus is occupant comfort. And if you go to the hospitals and lab, there are some other important parameter that helps you to design the project. Now, Occupant comfort is largely described at ASHRAE standard 55. We'll go through the standard 55 later on in this course. Now, just to make a quick call, process heating, space heating, cooling, ventilation criteria must consider when selecting optimum systems, as well as the following. So following are the consideration that will come when you are designing. Temperature, obviously, the very first contributing factor. Humidity. In many cases, humidity are important. Let's say if you are designing a HVAC system for a pharmaceuticals, humidity is a important factor. Air motions, the air pattern. Let's say if you are designing operation theater, air pattern is important there. So in some places you're going to need laminar airflow, and other places you might need laminar or turbulent airflow. Air velocities are important. So for sure you are not comfortable in very high velocity air. Also in some operations, high velocity air is discouraged. Let's say if you are making operation theater for any ophthalmic project, the air velocity must be controlled there. Otherwise, operation is not going to be, in the right manner. Water quality and reuse. Obviously, can have a focus on this. Outdoor air quality is important. Let's say if you're having a project in very polluted area, there must be special concerns. So that need to be remembered. Indoor air purity and quality, obviously, let's say if you're having a project in a commercial space, the indoor air quality will have a lower spec uh, than comparing with operation theater. Air change per hour is also important factor. Actually, the places with the high air purity, we need higher air change per hour. We'll be discussing this on later on. Acoustic and vibration. ASHA standards have described acoustic and vibration for different projects. We will study them later on. Local climate is important contributing factor. You must know what is the um, temperature, local temperature and local dB dry bulb temperature and wet bulb temperature. That will have impact on load calculation. So local climate is important. Mold and media prevention, we will have a focus on these capacities, redundancy, obviously, uh, safety equipment requirement, environmental health and safety design, security, uh, initial cost, return on investment, operation and labor cost, maintenance cost, reliability, flexibility, serviceability, controllability, replaceability, life cycle analysis, sustainability of design, seismic protection, filtration, especially for critical projects like hospitals, pharmaceuticals, food factories. Filtration is important. Changing code and standards. Right. So all of these are important factors that you are going to consider before designing a project. Now let's talk about equipment room. But what is equipment room? Equipment room are places where you are just keeping the chiller or AHUs. So total machines and electrical space requirement for HVAC system is actually between 4 to 9% of the gross area of the building. But in most cases, it is from 6 to 9% in range. So if there is a question coming from here, what should be the gross area? The answer would be 6 to 9%, not the 4 to 9%. 4 to 9% is actually the broader range. It is going to be in most cases 6 to 9%. So that would be our answer. Equipment room height. Equipment room height is mentioned here. It is going to be at least 10 feet to up to 18 feet, but it actually depends on the size of the equipment. Let's say if you have a higher, taller chiller, then you're going to have a taller structure. So that is actually mentioned here. So also, if you have to remember this one. Like from the slide one, as we have discussed, you don't have to memorize all this. You just have to know what is happening here. Just go through this. But these are the important information that you may consider memorizing. um, for exams, also for any interview. There'll be question. There might be a question from here. Okay, the shaft of the building, the vertical shaft. If the building is over 2 stories or higher, there is a vertical shaft required. So vertical shaft required only dedicated for HVAC system. Through this, you can take your duct, pipes, and relevant stuffs with the HVAC system. The vertical shaft will be one from top to bottom directly. The vertical shaft should not be adjacent to stairs. So it should be separated from stairs. Stairs should not be close to the vertical shaft. It should be in a separate place. Electrical closet should not be closer to this vertical shaft, and elevators should not be closer to vertical shaft. So vertical shaft, we need one for dedicated for HVAC system, which should be in a separate place from stairs, elevator, or electrical closets. Vertical shaft, the size ratio could be 2:1 or 4:1. Those are the suggested one. So these are important data that you may consider remembering vertical shafts. Yeah, yeah. Now let's move forward for the chapter 2. Chapter 2 is decentralized cooling and heating system. So there are centralized cooling and heating system and decentralized cooling and heating system.